Today's course will focus on building cross-platform Xamarin apps for Android and iOS. Let's start with the basics. What is Xamarin exactly? Xamarin is a technology for using C# to create Android and iOS apps. Anything you write using native technology in Java, Swift, or Objective-C, you can also write in C# thanks to Xamarin. It allows you to build native user interfaces, native controls, and native layouts. It gives you access to native APIs and allows your app to achieve native performance. Xamarin supports the latest OS versions available at the time of release. Supposing there's a new Android version out and you'd like to create an app using Android Studio for that version, Xamarin would update on the same day so you can use it to develop your app. Let's consider the common ways of building mobile applications. Most often, we'll stick to the silo approach with both competence and design silos. Different platform apps are developed separately. 3 separate teams work on 3 separate projects. You'd write an iOS app in Objective-C or Swift using Xcode. You use Android Studio and Java for Android. For Windows, it's Visual Studio and C#. What are the benefits of Xamarin? Using Xamarin for mobile development allows you to create all these projects in C# using the .NET framework. With Xamarin, you can stick to the silo approach, developing 3 separate apps that don't share a codebase. But because you create the software in C#, this lets you also to work as one team, collaborate, share knowledge and skills, and balance workload in one team working on 3 different solutions. This, of course, makes sense only if the app code is not reusable or the apps use system-specific APIs, like games that need completely different engines and other customized apps. The most common approach for Xamarin is sharing a bulk of code across platforms. There are, of course, platform projects that contain UI definitions specific for each platform and some services that execute platform-specific API instructions. We also get most of the shared logic written in C#, which typically includes handling databases, the web service integration layer, and above all, the business logic unit tests, and real-time communication, which we'll focus on at the end of this course. This approach lets you share from 75 up to 80% of the codebase. How it all goes depends, of course, on your team, skills, preferences, framework, and project type. If the project requires high complexity from your platform, if you use animation or platform-specific behavior, the shared code will be obviously less. Still, this is 50 to even 60% of the codebase that can be shared across platforms. We will focus on this approach during the course. Another approach uses Xamarin Forms, a framework that is also delivered by Xamarin. This approach involves sharing also UI definitions. A developer will be able to build a single user interface using abstracts provided by Xamarin. Between platform projects and their shared logic, there is an abstraction layer of the user interface. The UI can be written in C# or XAML. Obviously, Xamarin Forms still involves platform-specific projects for native services and application manifests to ensure that all projects are properly built and will produce a native app file. Unfortunately, this approach only works in the case of less complex apps since the framework uses ready-made controls. The apps are usually quite simple. If your goal is a more advanced app with excellent user experience, you should decide on the default Xamarin approach. Xamarin Forms is good for apps that display and operate on data where the focus is functionality and not a custom user interface. We'll look at this approach as well, and we'll create two Xamarin Form apps. We'll add a bit of flavor to it with Prism, which will allow us to optimize some steps and write testable Xamarin Forms apps for which we can build unit tests. Xamarin gives you 100% of the iOS and Android native APIs, the full spectrum of .NET. All namespaces, such as system.io, used for operations on files, system.link, a powerful tool that supports queries on objects, and system.xml, which lets you operate on XML files. Apart from the native API with MapKit and UIKit, Xamarin also brings other .NET elements that let you create more advanced apps in an easier way. If your developers know the .NET framework, they would be able to easily develop an iOS or Android app by expanding their knowledge of platform languages. It's similar with Android. Xamarin offers the entire .NET framework and Android-specific API. Of course, some API elements must be rendered to fit the .NET framework convention. They are expanded to include mechanisms that let you write your app using the best practices and the .NET framework convention in a consistent way. As already mentioned, Xamarin gives you native performance thanks to using the same compilation techniques. A Xamarin.ios app compiled in ahead of time would produce a binary file for the ARM architecture, which you can then run natively just like any app created with Xcode or Objective-C. Similarly, we use just-in-time to compile Android apps, so we'll prepare an app package, APK, which contains all the necessary elements for the app to execute and compile in an Android virtual machine. Previously, this emulator was Dalvik. For Android 5.0 and later versions, it's Android Runtime. Using .NET with Xamarin will allow you to develop apps for more than 2.5 billion devices. It's one of the most popular software development tools, especially for mobile. Xamarin offers two IDEs. The first is Xamarin.Studio, available for both OS X and Windows. It is most commonly used on Mac, and it will be our IDE in this course. I think it's much more efficient and faster than Visual Studio, which can be used with Windows and allows you to build Android apps. For iOS, we will unfortunately need to resort to a remote build host, a network Mac, that we will connect to build our iOS app. This means that although you can edit and write iOS apps, you can't build it up. Using Visual Studio, you'll be able, for example, to edit iOS storyboards, but to finish the app, you'll need at least one Mac device to compile it. During this process, a box pops up in Windows and the app launches. You could debug it and so on, though at the end of the day, it's a very slow process. It's much more efficient to use Xamarin Studio, especially if your focus are iOS apps. With Android apps, you can use Visual Studio with Windows easily enough. As I said, due to Apple licensing, it is not possible to compile an iOS app in Visual Studio, but there's no such problem with Xamarin. While maybe a future deal will let Xamarin implement this feature to allow us to build iOS apps in Visual Studio, at this time, Apple does not allow emulating or compiling iOS apps on non-Apple devices. As for distribution, Xamarin apps are 100% native. Xamarin output is nearly identical to native output, and distributing is analogous. iOS apps are released in the App Store. With an enterprise account, you can generate a provision profile which enables users to install the app on almost any device. If you don't have the enterprise account, you can generate a provision profile in the ad hoc mode and then register all the test devices in your company on a single developer account and sign the app in this mode so it can be run on your registered test devices. Publishing works just like with any native app. Android is the most flexible system. To distribute your app, you need to generate an APK and sign it using Keystore. The file can be released in Google Play or Amazon, or you can distribute it in any way you want. The Windows platform uses the Windows Store, formerly known as the Windows Marketplace. Distribution is the same as with native apps.